In this lesson, we're going to learn about histograms and comparative box plots. So a histogram, you can see I've got my axes already set up here. You've got frequency, or at least a frequency histogram. You have the frequency in the y-axis, and you have your class intervals in the x-axis. And those intervals can either be given to you in essentially divide your data set up into intervals of 20, say, or you can just decide on those intervals based on the data set that you have. So in this case, we've divided this data set up here into intervals of 0 to 9, 10 to 19, 20 to 29, 30 to 39, and 40 to 49. So in intervals of approximately about 10. So the first step is to draw a frequency table. Okay, so I've got my intervals here, and then I just need to count up the number of times that there are values that fit into this frequency. So I've got one value here that fits into the interval of 0 to 9. I've got 1, 2, 3 values that fit into the interval of 10 to 19. I've got 1, 2, 3, 4, 5 values that are between the values of 20 to 29. I've got 1, 2, 3 values that are in the interval of 30 to 39, and I've got one value that's between 40 and 49. So this is my frequency, and then what I have to do is go over to my graph, and I just take my frequency there for this interval. So between 0 and 9, I draw a box up to the value of 1. The next interval I have between 10 and 19, I have 3. So I draw myself a box from 3, just attach it up to the other one. From 20 to 29, I have 5. So we'll draw a box up to 5. And from 30 to 39, I have 3. 1, 2, 3. And then from 40 to 49, I have 1. Now you can see with this histogram, you can pretty easily see that the data distribution is fairly symmetric. So you have very few values on the outside, and they're evenly split between essentially the upper values and the lower values. Now we are going to draw a comparative box plot. So that's a box plot that we plot on the exact same axes, so we can really just look at what we see between a box plot and a histogram. So to do that, we need to find our quartiles and lower and upper quartile, etc. Okay, so our minimum value will be 4, our maximum value will be 48, and then we have to go ahead and find all our quartile information. So to do that, first we find the median. So I have 13 values. So in order to find the median, I could just go n plus 1 over 2 to figure out which value I need to find. So that would be 13, because I have 13 values, plus 1 over 2. So 14 over 2. My 7th value will be my median. So 1, 2, 3, 4, 5, 6, 7. So this value, 23, is my median. I then go ahead and draw brackets around my other two sets, and this is just a visual cue to essentially to let us know which are our upper and our lower 50% of our marks. So in between the bottom 3 and the top 3 values, I draw a line, and in between the bottom 3 values here and top 3 values here, I'll draw a line. So I know that my lower quartile will be here, and my upper quartile will be here. So my lower quartile will be Q1 equals 12 plus 15 over 2. And that's going to give me a value of 13.5. And my upper quartile will be a value of 34 plus 36 over 2, which will give me a value of 35. So that's all the information that I need to draw my box plot. Okay, so I have a value of 4 for my minimum, so right about here. Draw my dot. Okay, my lower quartile is at 13.5, so maybe right about, oh, let's say right about here. My median is a value of 23, so right about here. And my upper quartile is a value of 35, right about here. And my final value is 48, so right near the end. Okay, so I just draw a line to attach this one, a box to attach my interquartile range, right? This one is my upper quartile, my median, my lower quartile, and again, just draw a line to attach my minimum value. So as you can see from this box plot when we compare it, the box plot is, we have that median value very central to the interquartile range and also very central to the minimum and maximum values. So that's a really good example of a symmetric data set. Okay, so we're going to try another example now. And I'd like you to try it yourself before we go over the answer together. So just pause your video now and have a go. Okay, so starting up again. Okay, so the histogram, first step, yet again, we want to get our interval and frequency, and we'll be getting that from our data set. And make sure that this data set, it needs to be in order from lowest value to highest value. So if you're ever given a data set that isn't from lowest to highest value, make sure to reorder it in that way, because otherwise you'll have a bit of an issue. Okay, so entering in the frequency table, I've got 1, 2, 3 values in this first one. I've got 1, 2, 3, 4, 5 values in the second interval. I've got 1, 2, 3, 4 values in the third interval. I've got 1 value in the 30 to 39 interval, and I've got 40 to 45. Sorry, I've got 2 values in my final interval. So then I go up to my frequency table. Okay, I've got 3 values between the 0 and 9 interval. So I'll draw my box up there. The next one is 5. Draw that box up there. The next interval from 20 to 29, I've got 4. So I'll draw a box there. And between 30 and 39, I had 1 value. And then between 40 and 49, I had 2. So this is my histogram. Okay, so now what we're going to do is draw the comparative. I just cross-hatch that quickly so we can see that a bit better. So next one, we're going to draw the comparative box plot. So the steps that we need to do is figure out our 5-number summary for our lower quartile, inner quartile, min, max value, and median. Okay, so in this data set, I had 15 values. So if I go my nth plus 1 value to find which one my median is, that would be 15 plus 1 over 2, so that's 16 over 2. Okay, so my 8th value would be my median. So 1, 2, 3, 4, 5, 6, 7, 8. All right, so my median is 18. I'll draw brackets around either side just to visually show my lower and upper 50% of my values. I've got 1, 2, 3, 4, 5, 6, 7 values in each of these. So that means my 4th value here and my 1, 2, 3, 4th value here. Without any calculations, I can see that my minimum value is 5, my maximum value is 45, my median is 18, my lower quartile is 11, and my upper quartile is 27. So I'm going to go plugging that straight in using this exact same axis. So it has to be the exact same axis, otherwise we're not going to be able to compare well, right? So 5, I'll draw my minimum value with a dot, and my next value, which is my lower quartile at 11, right about here, attach it with a line. Then I have my median, 18, probably about here. My upper quartile is 27, so that's probably about here. And then I have my, where are we? My minimum value, sorry, my maximum value, right about here. Okay, so attach these all with a line and box. This is my interquartile range, this box here. and attach my inner quartile range to my maximum value here. So now if you take a look at this, you can see that this data set, and it's fairly obvious from this histogram also, that the data set is skewed, positively skewed, because there are less values in the kind of the upper range of the values as the lower range of the values. So my median is closer to my minimum value, and it's also slightly closer to my lower quartile than my upper quartile. And you can see that also in the histogram. There's kind of essentially there's bigger boxes on this side than this side. So that's just a way that you can compare the data that you have, how you can quickly figure out what your data spread essentially. And essentially that's everything you need to know about histograms and comparative box plots.